have Sten Vercammen, also from University of Antwerpen, and you will continue talking about mutation testing, right?
Yes, thank you. So, we can visualize a mutant easily and we can identify it easily because we can see it here. However, in software it's a bit harder. And like Ali said, there are a few problems. One of them is that it's too slow, especially if you want to integrate it into a continuous integration cycle, where you have a lot of integrations during a day. So the first idea that came to mind was to distribute it, especially in a cloud computing way. So traditionally, you have your source files, and then you mutate that by generating a lot of mutants, and then you will execute them, and then you can see the killed versus survived ones. But you don't have one file, you have multiple files. So the idea was, let's put this all in a queue. So here are all the source files. We will use one computer or more to generate all of the mutants and then execute them using multiple computers in a cloud or something. So first we need to verify that our initial build will succeed. Then we need to queue the mutants, generate the mutants, store the mutants on a file server, requeue down the mutants reference, execute those mutants, and then store the results and have the results back to the user. So there were a few interesting lessons we learned. The first was that while mutation testing is inherently parallel, so the speed up depends on the amount of workers you have, or the amount of hardware. So we could easily see that the scale up was quite good. And if we sum everything up, we see that there was very little overhead. So that's good. The second one was that the new cloud technology can easily be exploited. So I did something very easily, and I just distributed it and took the file server and put the source code on there, and then sent every project to each node. But that's a bit silly, because then for every node, the project will need to go to the switch, and you're basically adding a lot of bandwidth that you're not really using. So we can use a multicast to speed this up, or even use deltas, and then we will reduce the setup delay that we can see that increases again to its original delay. Thirdly, cloud infrastructures can have positive side effects. Why? Well, because you simply have more memory, because you also have more computers. And we can see that during the mutant generation phase, because we had more workers, if we add the cumulative times of the generation, it goes down. So this, in essence, means that we had better than perfect scaling, which was very fun. And then fourthly, the tasks should remain completely independent of each other. Because if we add like new technologies, like mutant schemata, for example, if these tasks start to depend on each other, it becomes harder to distribute. So, and the last lessons we learned that cloud technology leaves ample room for further optimizations, like compiler integration, mutant schemata, and test prioritization. For example, this mutant schemata, mutant schemata is one of the things we are looking into, and we are working together with SAP to bring this to their mutant schemata tool. And that's all I have to say today.
Thank you. Thank you, Sten.